Okay, on Moodle there is a box called Panopto on the right hand side. Moodle, as you see, has three columns, left, middle and the right, and the middle one has all the course week by week lectures, assignments, etc. But on the right you will find a box that's labeled Panopto, and it automatically adds these lectures that I record as soon as the class is finished, and it labels it with the date and the time. And I thought I will put a link, copy the link and put it in the middle, but apparently some people have access problems if you click on the one from the middle, but you're able to access it from the one on the side. I don't understand the reason. It may have to do with the fact that it's the link is treated as public link from Internet Anywhere, whereas this link is treated as from secure LSU login. But I hope if you want to use these recorded lectures for any reason, you are able to access it. If you are not able to access it, give me an email and I will look into how to enable individual access, what the problem is. Okay. So far we have 3 lectures that are recorded and automatically updated. There is one request by a student for switching the time of Monday lecture because it clashes with one of his lectures. Is that possible? How many of you have flexibility in your program to move it on a different date? So what date do you suggest?
Maybe Friday.
Friday would be bad because we have seminars Friday, and particularly when I organize that epic seminar, I'm tied all day with the visitor. I'm the host for those visitors, so Friday would be bad. Or can we have one 3-hour lecture per week on Wednesdays?
3 hours is fine if you have a
Break. Yeah, we will have a break.
On Wednesdays?
On Wednesdays, because his class is on Monday. He cannot make it on Monday.
But only if we can have 1 hour earlier rather than
Earlier, because you have a class afterwards from
Can
3.
I have a class before Wednesday class?
Okay, so so that idea is out. You cannot have a 3-hour lecture because both sides of this lecture are taken up. Hmm? On Wednesdays, yeah, we can shift that around, I think, yeah. Tuesday and Thursday in the afternoons I have a lab, so we are looking at mornings now. Because Monday is out, Tuesday, Thursday is out for me, Wednesday we are already there, Friday seminar out.
Can you just start Monday a little late instead?
Monday, can we start late?
I have class after this.
You have a class after this, right? And you have a class before that too, on Monday also?
No, not Monday.
No. Would you be able to make it before?
For
Monday.
I have a class from 12:30 to 1:30, but I'm
What
free
time?
1:30 to 3.
1:30 to 3, will that work?
Mondays?
Mondays.
1:30 to 3. My class starts at 2:30.
2:30.
It's the worst time ever because I work in the lab and it's in the middle of the day. So I
Okay.
have to finish everything, go back, come here, and then when I go back there, I have to wait, for everything to stabilize for at least 1 hour. I was
Okay.
actually gonna ask if we can push it to 4, but I think that's
4.
impossible.
Would that work on Monday?
4. The class is 2:30 to 5.
2:30 to 5. So that's only 1 lecture a week, I guess. Right? 2:30 to 5. I don't see a solution other than.
Or we can make a longer lecture on Wednesday and a shorter lecture on Monday. Does that work?
But-
Still
He cannot come
at all on
Monday.
Monday. Yeah.
Okay,
Tuesday,
so on Mondays.
But Monday you don't have, right? It doesn't work for you.
He doesn't, definitely doesn't.
Doesn't work for him. Yeah. right. Saturday. How do you feel with listening to lecture? Does that help, or do you feel being in the class is more helpful than just listening to it from lecture?
I like the videos.
You like the videos, so it'll work for you?
So except if something else is happening in class, I have to get, no,
Right, so you'll be able to attend Wednesdays, and I will give you special attention on Wednesday. Special questions, more time for you. Will that work?
Yeah.
Okay, so let's just stick with that. I'm sorry I couldn't find another time. Okay. Any questions before we begin? Okay, the last lecture we started looking into the use of these tools. So it's essentially last lecture today and maybe the next 2 lectures are going to be introduction to MATLAB and COMSOL with the goal of learning how to set up and solve problems of each class that we identified in the very first lecture. That is linear and nonlinear equations, algebraic equations, differential equations, initial value type, boundary value type, and then PDEs. So by the end of this set of 4 lectures, I don't expect you to become expert in MATLAB and COMSOL. I'm not an expert in MATLAB and COMSOL. That's not the goal. Okay, the goal is to give you enough confidence that you know what is possible, the art of the possible. And then if I give you a problem, you should spend enough time to be able to solve that problem using these tools, MATLAB and COMSOL. So what that does for me is prepares you to solve a variety of problems in assignments. So I will keep giving you problems of different types. The first assignment, for example, is on linear algebra. The next one would be nonlinear equations. The next one would be ordinary differential equations, initial value type, boundary value type, PDEs, etc. So we will build your skill to be able to learn MATLAB and COMSOL on your own after I have shown you how to go about learning. Okay. So the best thing I think that I can do in any course is teach you how to learn. Okay. So if you know how to learn, then you're on your own. You can learn whatever it is that you want. So it is only from that point of view. It's not going to be an extensive coverage of all the MATLAB features because there are 10,000 functions. I don't know all those functions in MATLAB. I always say that I know probably less than 5% of MATLAB and 3% of COMSOL, right? Because these are very powerful tools. And what you should learn is to learn on demand. Oh, I need to solve this problem. How do I go about setting it up? What kind of help? What kind of framework do I need to set it up? So that's my goal for the next 3 or 4 lectures. And I will do that and contrast it between MATLAB and COMSOL. One is a scripting environment, other one is purely driven by graphical user interface. And as we go along, we will see examples that is drawn primarily from chemical engineering, mechanical engineering, heat transfer, mass transfer, fluid mechanics, etc. So in the last lecture, we were looking at this so-called multi-component flash problem. Now, before I do that, any questions on your current assignment? Are you guys doing all right on that?
Actually, I have a question. So,
Yeah.
in the A part, you say that we need to define a forcing vector B and keep everything 0 except for the last element is 0.8. While you said to write the function for just creating a tridiagonal matrix. So
Yeah.
Just it's supposed to be a 1D array, that's it.
It's a
Because the use of B is not actually directly written except for the B part.
Are you asking about this part A or?
Yeah.
In part A, you're going to construct, so that's only writing the function file. Write a MATLAB function file that will accept A, B, C, and N. N can be any number, 10,000, 100,000, whatever, and construct that matrix T and return it to you.
No, so my question is, does it have to additionally even construct the forcing vector B? Because the inputs are A, B, C, and N.
Oh, okay, I understand that. So that's for specific problems that you're going to do, you have to use those numbers. Okay. But there's really nothing that you want to do in part A. Part A, if you write a function and list it out and test it out, that it produces a true triangle. So you can use those numbers to test out for a 3x3, 4x4 matrix or something like that.
So I'm not talking about the numbers over there. So the second last sentence, let the forcing vector be 0 except for the last element, which is 0.8. And over there in the images you show that B is like part A.
Yeah.
So the function has to create T and the array D.
No. Keep the function that constructs only T.
Okay.
B you will construct when you're solving
Okay.
the problem in other sections. And the structure of B I have given here, but I'm saying that this is 0, so it's only the last element that's going to be 0.8. Whenever you are having to solve, like in B, for example, you're solving Tx equal to B. So there you will construct a vector B that has 0.8 in the last element. The length is adjusted automatically accordingly, right? Yeah.
I didn't find the code generator, so I don't know how to produce the output as a PDF.
Right, that's a good question. I'm going to show you today. Okay, I have an example. As I do the example, I'll show you how to generate a PDF report in MATLAB. Any other questions?
The first part of the question, you said that AI equals minus S above that.
Oh, here, yeah.
AI equals minus S and DI and CI. You've given us the value of AI, DI and CI, and then on A, question number A, you've given us values of A. So that's just S is equals 1. Okay, so is that for the entire question, or do we have to input S for the remaining part?
No, use the numbers that are given in part A for.
So basically, the tridiagonal matrix T is constant, so you don't have to. It's just the size of the matrix that can be changed.
In this problem, that's what you are changing, right? The matrix is a constant matrix. It's a linear problem. So the matrix has to be a constant matrix, right? But the goal here is to see how the time required to solve a problem scale as the problem gets bigger and bigger, okay, in MATLAB.
And one more question number E. This
Yeah.
an analytical solution. Are we going to discuss this in class today, or
Nope, I don't have any plans of discussing it. So what do you want to know?
it's just that I'm not familiar with that?
Do you know what an eigenvalue is of a matrix? Okay, so there is a function called EIG that you will use to calculate the eigenvalues of a 20 by 20 matrix, T matrix that you construct. Okay, and because it's tridiagonal, there is an analytical solution for those eigenvalues. Analytical solution meaning you can explicitly calculate the eigenvalue according to the formula that I have given here. Okay, so plugging in the numbers on the right hand side, you will be able to calculate all the 20 eigenvalues without using the EIG function. And I want you to compare the two.
Okay, so J, what is J in that?
J is the number going from 1 to 20. So J equal to 1 is eigenvalue 1, J equal to 2 is eigenvalue 2, etc. Okay. Now, yeah, this is the purpose of this assignment, is to kind of get you to open up MATLAB and play with it and recall from your linear algebra course some of these concepts of what eigenvalues are. And in part F, for example, I say use the function EIGS. That just enables you to know that there is a function called EIGS. You may never have heard about it before. Then what do? Type help EIGS, see what it does. And what it does is it calculates selectively a few eigenvalues. So if I have a matrix that is 20 by 20, I have 20 eigenvalues. But I want to calculate only 4 eigenvalues. Okay, that function, EIG, will give you all 20, and it's a very computationally demanding algorithm, whereas EIGS will give you as many as you need. Okay, And the question then is, okay, how does it select? If I have 20 and you say, give me 4, how does it know which 4, right? So it says near a particular value. So you give a value of, for example, 3.1. So it finds the eigenvalues that are closest to 3.1, 4 eigenvalues that are closest to 3.1. And when we do later linear algebra review, we will see what algorithms are used, what ideas are used to calculate selectively certain eigenvalues. And why would one want to do that? Okay, so in fact, we will talk today about multiplicity and stability concepts as we are solving one problem. And we will revisit nonlinear dynamics in some detail. And there you will see why is there a need to calculate only a few select eigenvalues to see whether a system is stable or not. Okay? So the purpose of this is if you don't understand exactly what every function does, it's not that important. Just get used to using MATLAB, opening MATLAB, going through this and finishing the tasks. Okay? And the tasks are fairly simple to do. You need to figure out by using help EAGS what is the sequence in which you have to pass the information, how do you pass the information of how many eigenvalues you need, and where is it centered at. All these are input to the function. You need to figure out that order. So it forces you to learn MATLAB on your own. Okay, any other questions? Okay, so that screen goes out. So I should open this actually with I don't need that. Just give me a second. I think I opened the wrong file. Not the assignment, but lecture 4. Okay. So we were looking at this particular problem in the last lecture. Okay, so we saw how to do this in COMSOL. Essentially, we took n as equal to 4. I guess. So we have k1, k2, k3, k4, z1, z2, z3, z4, and we were asked to find psi. So it is a nonlinear equation, a single nonlinear equation, and we entered the whole function into COMSOL and let it solve. So I'm going to do this now in MATLAB to show you how one would write the MATLAB and use this example to show how to generate the report and how to debug the code as well. So let's start MATLAB. Oh, I'm going to have a problem. If I don't get license, I cannot demonstrate it. MATLAB used to be kind at one time to instructors. They will give you an instructor license which doesn't depend on the network license. It's unable to connect to the license server, but I am connected to the internet, so I don't know why. Refused. This is bad because what I need to do is now just show you the code and explain the code instead of running it. I am connected on the internet, so I don't know why. Okay, so let's write the function. We may not be able to demonstrate it by running it, and then I will show you what tool in MATLAB will allow us to solve any nonlinear system of nonlinear algebraic equations. Okay, so the basic problem in MATLAB is posed as follows. Okay, so f of x p equal to 0, and specific algorithms we will see later on. So when I put an underscore, it simply means that it's a vector, meaning I have many components in that. So x could be a vector of state variables, x1, x2, x3, x4, and 0 is the null vector on the right hand side, and f is a vector of functions. Okay, and p we call the parameters in the problem. So in this particular problem, k will be a set of parameters, z, the feed composition, will be a set of parameters, meaning they are known. They are constant values during the solution. So the vector x in this case is not a vector. There is only one unknown, psi. Okay, so in our case, x is essentially going to be only psi as the unknown. So in this particular case, what does this problem mean? If you give me the function and I say find that value of x which makes that function equal to 0, in this case find me that value of psi that makes the function equal to 0, it means that if I call this as my function, which is a function of psi, I can plot that f as a function of psi between 0 and 1 in this particular case. Why between 0 and 1? Because in formulating the problem, I have defined psi as the fraction of feed that goes to the vapor. The fraction has to be between 0 and 1. So when I put different values of psi into this function, I will have to write a MATLAB function that will take that and implement the rule that you see in this equation and return the function value. And that function value is not going to be equal to 0. But I can plot each one of those. So if I take 10 data points between 0 and 1, and I pass on 0, 0.1, 0.2, 0.3 to this function, and it returns the corresponding function value, I can plot them, and I connect them, and I know roughly where my root is, which value of psi makes that function equal to 0. Okay, and that's visual part. That's only possible when I have a single equation and a single unknown. If I have 10 equations and 10 unknowns, 2 equations and 2 unknowns, it becomes much more difficult to graphically see where the solution is. So MATLAB has a function called fsolve, and that's what we are going to learn today. Okay, so the fsolve's purpose is to solve a function, make the function equal to 0, and that function can be a vector function, meaning many function values, and a function of as many variables. So if I have 2 equations and 2 unknowns, I can solve for that. 3 equations and 3 unknowns, I can solve for that. fsolve will do that process. And hopefully, if I can get the license in time, I will demonstrate it. If not, maybe I will record it later on and put it on Moodle. I'll keep checking from time to time. The license server is down. I think that's what this is saying, because I'm connected to the internet, not able to check out the license. So how would I write this function in MATLAB? Okay, so right now, since I cannot start MATLAB, I can use only Notepad. This is not going to be the ideal lecture today, I apologize, but we will see how much we can do. So my goal right now is what? To write a function that will implement this rule, this evaluation of this function, for a given value of psi, for a given set of parameters for k and z. I need to encode that in the MATLAB language. The way that you do that is you always start the first keyword as function. That tells you MATLAB that you are defining a new function. As I said, MATLAB has 10,000 different functions. Sine is a function, exp is a function, eig is a function. That means it has some definite input variables, it has definite rules to operate on them and produce a definite output. LU is a function that has similar roles. So we can extend this MATLAB tools by writing our own function, which is what you're going to do in your first problem, first assignment. You're going to write a function called TIRD maybe that takes those 4 inputs and returns T. Okay, so in this case, I'm going to return my function, and I'm going to give it a name, flash, and I'm going to identify what inputs are needed. Okay, so psi, k, z. Okay, so I am declaring what is the name of the function. It's called flash, and it requires 3 inputs. It's going to produce 1 output. Okay, and notice that I'm not specifying how long k is, how many entries are there in k, how many entries are there in z. So it's implicitly defined in MATLAB. That's one of the strengths of MATLAB. So once you write this function, you can use this for a 4-component system, for a 20-component system, by simply defining the length of the vector as 4 or 20 when you call this function, okay? Not when you're defining it. And then the next statement I want is, I want to calculate and return that function, right? So I'm going to, somewhere in that function, I must have a statement f equals, because it is that f that is returned, because that appears on the left-hand side of that equation. Okay, f equal to flash all the inputs. Flash is the name of the function, and left-hand side is the output, and everything in the parentheses on the right-hand side is the input, right? So I'm going to now encode this entire statement, and I'm going to do it in a way that is just 1-line code. Okay, so I have the summation, sum 1 going to n. So there is a function called sum. I'm going to use that. Sum is a function, so it will take certain inputs and sum all the elements in the vector. So sum is essentially a function that takes a vector, adds all the elements, return a single number. Okay, so inside that sum, so I've taken care of this sigma symbol, summation symbol. Okay, and inside that function, I'm going to write 1 minus k, and that 1 minus k, k is a vector. Could be of any length, 4 or 400, whatever it is, right? So 1 is a scalar. So every element in k, it will be minus from 1. So the result will be a vector. 1 minus k will be a vector, okay? And I want to multiply that by z. So I can put star z. That won't work because I need to indicate that ki is multiplied by zi. This is so-called element by element multiplication. So indicate that I need to put a dot star. Okay. So now I have coded the numerator. 1 minus k multiply dot by dot element by element multiplication. So dot star z. And then I have to work on the denominator. Okay. So I normally bracket together so that I don't have a missing bracket problem. Okay, and then in the denominator I have ki minus 1 times psi. Okay, so k minus 1 times psi plus 1. Okay, and I just semicolon suppresses the output. Okay,
Bracket.
do I already make did I make a mistake?
Yeah. Well, k minus 1. When you close the bracket, you close the sum.
Okay. I was trying to be careful, but with programming, there's nothing like being careful, I guess. But of course, you should be able to pick it up while running it. Syntax error, it will immediately tell you. It won't even run. Okay, question?
Yeah, don't we? I think we need another parenthesis, pair of parentheses for the denominator to take plus 1 inside.
Yeah. Why did I miss that? So I need to put that. And then I need one more, right?
Yes.
I think there's one extra.
4 or 5, there is one extra, yeah. This is a beauty. If I had MATLAB, as I'm typing MATLAB, you will see that it shows the matching parentheses, right? Now I'm doing it in blind.
No, it's done.
K minus 1 times Z, that part is clean, and here
Yeah,
It's correct.
K minus 1 time plus 1 divided by this, right? And then you need to end this with a command. That's all. This is how you define your problem to MATLAB. Okay. Now you can do a lot of things. You save this in a folder. You can call this from within MATLAB. You can execute it. You can pass it to another function that will solve the problem, etc. Okay. So the same function can be used for plotting, for solving as an algebraic equation. we will see another example where we use the same function for solving differential equations as well.
So f, when it is returned as an output, returns just a single number, not a
It returns as a single number. That's a good question, right? So in this case, I've designed it in such a way that it will take only one value of psi and return a corresponding value for f. Now, can you make it general so that it takes 10 values of psi and returns corresponding 10 values of f?
If we remove the dot over there, it will actually give a matrix directly.
If you remove the
Dot star dot.
then it will give you a matrix, you think? That depends on whether it will give you a scalar or a matrix. Now,
We have something different.
no, the sum will collapse it. Sum is actually, all the functions are very general, right? So if you pass a vector to a sum, it will collapse it into a single number. If you pass a matrix to sum, it will collapse it on one dimension. So it will add all the columns and give you a vector. But you can also ask it to sum on all the rows and give you a column. So you have that ability to the sum function to pass a scalar, a vector, a matrix, and identify which dimension you want to do the summation on. By default, if it is a vector, just a summation of all the elements. So this is the minimum thing that sum needs, a vector. But if it is a matrix, then you have to be more careful to see which direction you want to add them up. Now, 1 minus k star z will produce either a matrix or an error, depending on the dimensions of those two vectors. Okay, so if k is a row vector and z is a column vector, it will produce a scalar number. It treats it as an inner product. Okay, if k is a column vector and z is a column vector, it will give you an error because it's not a compatible product. Okay,
I have a question. Are you recording everything?
I am recording. I'm
The
recording.
other question is when we call the function in the command file, we input psi, k, and z.
Yeah.
For each one, we input one vector or one vector.
Yeah.
But we have a summation. How do we input like different psi and different k and different z?
Psi, this function is designed such that it takes only one value of psi
Yeah, one
and
value.
returns one function value for that psi. Remember, the problem that we are solving is this that I illustrated. So I guess a value of psi and I pass it to that function. It returns a number. I plot it here. And I then send another value of psi. It returns me a function. I plot it. So to generate this entire curve, I have to call this function 10 times, 100 times, however long that you decide. That we will do by putting a loop around the main function that calls this. So this is the problem I want to solve. How I solve it is going to be done by calling this function repeatedly from a main function.
What about the k?
The k and z are vectors that will also be assigned a value when I call this function from a main program.
If
Okay.
you want to use this as an inline function, do you have to, like as in we write a program and define the function in the same program itself, the same script?
Right.
Do we have to?
You can do that. That's a bit more advanced use of the feature. That is, there are two things: inline function and then the sub function. Okay, inline function is essentially a one-line function that you write in the command window or a script, and then you can use it anywhere that you want. But it is known only within that file. Whereas this one, when I save it in MATLAB, every function in MATLAB can access to it as long as it's in the search path. So this is the best way, most elegant way of writing small functions to extend the MATLAB's toolset and then put it into the path. Okay, let's try whether MATLAB will start. Unfortunately, nope. Any other questions on this? So how do I? So I'm going to save this. Lecture 4. It's called the text file. You should call it as .m. Otherwise, MATLAB doesn't recognize. Okay, so flash l.m. So I'm calling this function as flash l. So maybe I should also. There is no correspondence. Yeah, there is no correspondence, but it's nice to have the same name here as well.
So regarding that, I was trying it yesterday. So the corresponding thing is only from 2015 onwards. If it's an older function, MATLAB doesn't read the function properly. It has to be the same name as the.
Oh, they have started imposing this? I don't know.
Because in the older one, in the newer one, you can name it as however you want.
No, it has always been like that. That is, the file name is the one by which it searches, because it searches only the tree structured path. So in that path, if it finds that file name, then it expects to find whatever function that is inside. It will just execute that. So if there is a mismatch in the names, it wasn't enforcing that very strictly in the past. That I remember. Okay, any other questions?
Yeah. Can you explain what is summation of I to n?
The summation of I to n simply means that you're going to have this term 3 or 4 times, and you're going to add them up. So if I want to expand this function, okay, to expand this, you know what the summation sign means, right? So suppose I have 4 components. So I'm going to give you k1, k2, k3, k4, z1, z2, z3, z4. Okay. So the first term in this one would be 1 minus k1 times z1 divided by k1 minus 1 psi plus 1. That is I equal to 1. Next, I will have the same term plus same term with 2 replacing 3 and 4, right? And
the number of total number of terms.
yeah, n is the total number of terms. It's the total number of components in the distillation example. Yeah. But that n really doesn't appear in this function because MATLAB's ability to handle that length of the vector implicitly. Okay, any other questions? Now, having written this and saved it, so percent in MATLAB means it's a comment, it's going to ignore. So you can put whatever you want to explain what you're doing. And a double percent means that it is starting a section in producing the report. Okay? If you want to produce nicely formatted report, you want to make the distinction between double percent and single percent. Okay? So, and then you say, so this is just a function to drive, meaning I'm going to call the flash and get some jobs done. Okay? What is the job I want to do? I want to define k. This is where I define the values of k. So I can define it as 3, 2, 1, 0.5. It can be 10 numbers if you have a 10 component system. Okay, automatically that will take care of. And similarly, z as 0.25, 0.25. So I've defined 2 of the variables that are needed for that function. And then I can do this. Those that know loops, you will follow what I'm trying to do here. For psi equals 0.1 to 1. So what this does is it sets up a loop for every value of psi going from 0 to 1 in steps of 0.1, do whatever is in the loop after this, and that loop will be ended with an end. That shows the for loop beginning and for loop end. Whatever contents inside that will be repeated for every value of psi. Okay? And here I can say f is equal to, I'm going to make some deliberate mistakes and see whether you can catch that. Flash L psi comma k comma z. And then I come out of this and then say plot 0.1 to 1 comma f. What am I trying to do in this?
It won't work.
Why?
Because you are rewriting at each time.
Very good. If everybody followed that, I'm very happy. I don't need to spend so much time in explaining MATLAB. Okay. So what am I trying to do in this script that I'm writing? This is not a function. How do I know it's not a function? First line doesn't have function. So that's the indication that it is not a function. So it's just a script. Doesn't have any input, output, no structure to it. You can put any MATLAB command, it will just execute it in sequence. Okay. And so in the second line, I'm defining values for k. In the third line, defining values for z. In the fourth line, I'm setting up a for loop, and I'm defining the variable psi to take on values of 0, 0.1, 0.2, 0.3, all the way to 1. And in the next line, I'm making a call. I'm passing the control to flash L that I wrote and saved in my workspace. Okay? And that requires 3 inputs, the way that I wrote that, psi, k, and z. So I've given values for all of them. But psi will automatically pick up the value from the loop increment, right? And that value will go in here. So the first time it will go in with the value of 0, second time it will go with the value of 0.5, 0.1, etc. But when it comes back with one number, and that number is stored in f. It keeps overwriting that f. So even though it goes through 11 times, 10 times, whatever that number of times, it's going to carry only the last value. And in the next line, I'm expecting to plot on the x-axis. This is the plot command, plot x comma y, right? So on the x-axis, I'm saying go from 0 to 1 in steps of 0.1. These are the psi values. On the y, I'm expecting to plot all the function values. That's not going to work. It's going to produce an error because I have 11 values on the x-axis, y value, only one value on the y-axis. How do I fix that?
You can put a
Yeah.
counter.
You have to put a counter because the array has to be an increment, integer number. Psi is a fractional number. So if you put f of psi, what problem will you have? It will have f of 0 first time around. MATLAB doesn't allow 0 subscript. It starts at 1, right? So it will again give an error, and all the others will be truncated to 0. 0.1 will be truncated to 0 as an index. So you need to create an increment. Or MATLAB has another feature you may not know, which is to define f as a null vector. So if you put it within square brackets and don't put anything, it's null. It knows about f, but it contains nothing. Okay? And then what you can do is, you can, because now you have declared what f is, you can do this. Sorry. So what it does is takes whatever f that was previously there and appends one more number that is returned by this flash function. So the first time around it goes through the loop, it will have nothing, and I'm adding 1. You follow? So in this line, I'm declaring f to have nothing, blank, right? And when I come and execute this for the very first time, I'm saying the new f I'm going to assign on the left-hand side is going to consist of the old f on the right-hand side, the very first element, right? And then a call to flash, and whatever that returns, you add it to that. Yes or no?
So every time it generates one array, add one array to the
It increments the array dimension by 1 every time you go through it. Okay? So it produces an array of f that is as long as psi. Okay? And then you can go expect this function to work. There are a lot of these little things that you can learn by looking at code. I will upload some examples of these codes onto Moodle so that you can download and study them as well and use them as templates for modifications. And then use the help command in MATLAB to learn about related commands and slowly expand your expertise in MATLAB. Any questions on that? The other way, if you want to do it your way, how would I do that? I would get rid of all this. I would put a counter, right? But I need to keep incrementing the counter. So instead of f equal to that, I will put I equal to 0. And then I will increment inside that. I is equal to I plus 1. Right? Then it will keep incrementing I, and then it assembles the vector.
So FIs are saving into our memory every time, and then we call it for plot, right?
Yeah.
That's what happens.
Right, exactly, yeah. So there are many ways to tell the story, right? No two functions will be the same, but you achieve the same goal. One more time. Lucky. I'm excited. Now I can run things, right? All right. Let me close one of these things. Because now I can't show you how to publish. So this is the function that I wrote, but I'm double clicking on the function file name to open it inside MATLAB editor. Okay. So as long as the path is set to that, the path is set here to that folder that contains the function, MATLAB should know about it. How do I test it? I can just say type that function name. Okay, so it lists that function. Okay, then I can execute it. But before I execute, I need to define the values. For example, k is equal to 1, 2. I take a two-component system. Okay, and then z is equal to 0.5, 0.5. Okay, so I've defined k and z. I can call that function by typing the name and then giving a value 0.25, k, z. I've defined k and z, right, in the previous lines, and they are available in the workspace. You can see here, k and z are available in the workspace, right? And I'm giving 0.25 value to psi implicitly as I call this, and the function value is minus 0.2439 at that value. Yeah.
Next time when you give it another sign, it's gonna add it up or sum it to the value.
No. Every time you pass a different value, it will return one value. So if I call it again with 0.5, I'm calling directly the function. I'm not showing you the other function that I wrote. I'm going to show you this later. But this is just to test whether the function is free of errors. So if I pass a set of 3 values for psi, k, and z, does it give me one value? Okay, and it does. Okay, now I'm going to open up the other function. What did I call that? Maybe I didn't save it yet. I'll call this as flash script.m. Okay, and I can close that. And flash script appears here, so I double click on that. It opens that script file that I wrote. Okay, so pardon me? Do you want to turn it off?
Yeah, there's a glare that comes.
Sure, please go ahead. Okay. Just turn it off. Now you have the.
What is
Yeah,
what is
it's
the
very
source
weird.
of it? Maybe it's from the projector.
It is from the projector. Yeah. Is it bad for you now?
No, it's fine, but I think it's worse from the other.
Yeah,
angle.
this
Seeing it
I
exactly.
can't see it.
I can see.
You probably have to move around. I can see it from this part. Maybe there's a lot of room up to the front, something like that. I don't know how to fix that problem. Yeah, feel free to move around, find the place that's best viewing for you. Okay, so now we are going to run the script, and the script is going to call flash L several times and build that function and plot it for us. And then I'll show you how to use the fsolve with that. So there is another feature, I don't know whether you're familiar with it yet, it's called debugging feature. So when you're running a script like this, you see these lines, each one is an executable line. That is, MATLAB decodes that and acts on it, whereas comment it ignores. So in these lines, you can just click and it puts a red dot. That means you have set up a breakpoint. When it comes to execute that line, it will stop execution, pass the control back to you, and you can then step through. And it's a very powerful feature for you to look at how to where the bugs are. So once you set up these breakpoints at strategic locations, in fact, I don't need it there. I'll probably need it here. I'll put it there. Okay, and then I say run. There is a run button there. I click on that, and you see the green arrow saying that it has executed all those lines before that. It's waiting to execute that particular line. So if you take the cursor near k, it shows you what are the values of k it has assigned. Similarly for z. And it's also available, of course, in the workspace, right? And I is declared as 0. And now you can control line by line. So there is a button there called step. Step means it's going to just execute one line and pass control back to you. And you can still look at what is happening. So I will step once. So what do you think should be the value for psi? 0. So you take it near that and you find the value is indeed 0, right? What should be the value for I?
Before it enters that line 0, after the line.
It hasn't executed line 6 yet. So it should be 0. No matter where I appears, you just take it near I, it will always show you the current value. Okay. Now if I step, now I will be 1. All the locations, because it shows you the current value of that symbol. Okay. And now what's going to happen?
It calls the function.
It transfers control to flash L with all the values that are defined here. So psi is defined as 0, k is defined as this vector, z is defined as this vector. Right? So it's going to pass the control to flash L and take the value and assign it to F1 and then move on. But if you want to look at how this is executing inside that function, you can go to flash L, which is where the control is going to. You can set a breakpoint there. Okay? And then come back and continue. Step. So the control was passed to flash L, and now it is stopping there because I set a breakpoint there. Why would I want to do that? I want to make sure that I'm passing all the values right. So what is the value here for psi? 0, k, 321.5, 0.5, 0.25, 0.25, 0.25. Now inside this function, you could have called psi as something else, because these are all local variables to that particular function. You could have just called it p, you could have called it lambda, whatever it is. But the value is passed by location, by reference, right? So the first variable in the calling function will pass the value to the first variable here. Inside it, you can call it consistently as any other value. Now you can step. Now it has calculated the function, one value. There it is, 0.1562. What do you think would happen when I press next step? It should return back, and you will see that it gets prepared to go back. And then if I hit one more time, it goes back. Now f would be a vector of length 1 with that function value. Now if I hit step, what do you think should happen? It goes back. Okay. Now what is the value of I?
1.
Still 1. Okay. If you are following that, I think you are pretty good in programming. Now it will be 2. Now it will go back there. So I can get rid of this because I know it works. So the next time around, it doesn't stop there, right? Now what is the value of I? 4. What should be the length of f? 4, because there are 4 times it has executed, so there are 4 values for the function. Okay? And now I can take that out and put a breakpoint there and continue. So it has done all the 10 times. Okay? Now I can plot. So f would be like this. And there is my function. Okay? Now, do I have a root between 0 and 1? No, because all of them are in the negative. So my k values were not right in the sense that they're all in the liquid phase or vapor phase. It's not separating into 2 mixtures. Okay? Any questions?
The function that you called has to be the same so that
Yeah, the function has to be in the same folder as the script file. Or, there is always an or, there's one way of doing it. You need to add the path that you see here into the MATLAB search path. Search path. Okay, so there is a command called path, and it will be huge path because these are all toolboxes that MATLAB has. It's about 50 lines or so. You can add your own current directory into that path. Then it will pick up automatically. Okay? I guess current directory is automatically picked up.
Yes.
But if you put it somewhere else, you have to put that explicitly as the path. Yeah. Okay, so I need to play with this k values. So maybe I will make it as 2, 1.5, because I need to find a root before I can show you how to use fsolve. Okay, so let me save this and then run it. I can take all the breakpoints because I know the whole function works, so I can just run it and see what happens. Do I have a root? I do have a root now, right? So you can do this trick only for one equation in one unknown. If you have two equations and two unknowns, this you cannot do, right? Graphically, you cannot look at the thing, but you can use fsolve. Okay. Now, before I go and illustrate fsolve, which is a powerful tool in MATLAB for solving any number of nonlinear algebraic equations, I want to show you how to publish, because for your project you need that, right? So there is a folder here called publish. Okay, and in that you have an icon called publish, and if you select that, it says edit publishing options. You select that, and you have the output file format. Normally it produces the output as an HTML file, but you can choose it to be a doc file, a LaTeX file, PDF file, whatever. Let me pick PDF file, and then I say publish. What it will do is produce a PDF file that contains all the code and the output. So here is a PDF file. Okay, so here is the script to drive the flash function. Where was it? It was in the comment that I put. Okay, and then it is the piece of code that I wrote. Okay, and here is the plot that it produced. In here, I didn't have a statement to list the flash function. That's why I don't get that flash function. Okay, in your assignment, you should make sure that any function that you write is also produced in the report. And the way to do that would be close this and go back, and maybe at the end of it type flash L. Okay, and then save that and then publish that. So when you publish that, it actually runs the script, produces the graphs, captures the image, puts them all into a PDF file. You can do that in a Word file. That means you can edit the Word file. Okay. Here you see type flash, and here is a flash function. Okay, and that was the script. You can have multiple sections, and if you have multiple sections, it produces beautiful table of contents, etc. The report generator is very good in MATLAB. Does that answer your question about how to produce the report? You had a question, okay? Any other questions? Okay. Now the thing that we need to learn is how to solve, meaning how to find that precise value of psi. We know approximately where it is from the graph, but how to find the precise value of psi that will make that function equal to 0. So the function is called fsolve. So type fsolve, and it produces a large document. It just scrolls past. If you want to read that, you need to kind of open this window, or you can just click on this documentation on fsolve. It produces a nicely formatted HTML help file. So f of x equal to 0. It solves general class of nonlinear functions like this. How to use it? You have to use it in this format. Again, I don't know how to blow this up. Okay. Control plus works. Okay. So the way to use that is x equals fsolve. Fun. Fun is the name of the function file that you're going to write. In our case, it's flash L. We have already written that. That's how we give the problem. And x0 is the initial guess for psi. So we tell fsolve, we give it a help. Say try around 0.5, for example, psi value. So then it sends 0.5, gets back a number that's not 0. Then it starts using its intelligence to guess better and better values of psi that will drive the function to 0. Okay? So as a minimum, you need to have these. But you can also have something called options. Okay? So through the options, you control what should that fsolve display, print out, and what should be the accuracy that you want. Do you want 4-digit accuracy for the function to be 0? You want 14 digits accuracy. So there is a machine precision, which is about 16 digits in MATLAB. You cannot get anything beyond that, but you can control the error within that. So I'm not going to spend a lot of time explaining options, but I'm going to kind of add that code from, I guess, just cut and paste. Where is that? No. Flash script. Yes. This is what we wrote just now. Okay. Yeah, here it is. Okay, that's the one line that transfers the control to fsol, telling fsol to solve the problem that you find in flash L. Okay, so I need to put that code. What happened here? I minimized something. I don't know what I did.
You have two MATLABs.
I have two MATLAB sessions? No. I think I just the window. I maximize the edit window. But let me see. Completely different. Okay, let me just close this and restart MATLAB. Oh, here I have. You're right, I have two windows. Okay. So I copied the fsol function line, and I want to put it on my script that I wrote here. Okay. So this is the script we have been writing, and as a last line I say psi, the converged value is stored on the left hand side here, and I'm passing the control to fsol and telling fsol solve this function. I need to fix that there because I'm saving this function as flash L. Okay, and telling it that this function flash L has 3 inputs, but fsol should know which is the one that I'm actually solving for. So I indicate that with this. So the 3, fsol should focus on changing the values for psi and driving the function by doing that. Okay, so the add sign within parentheses psi, name of the function, input parameters to the function, comma, 0.3 is the initial guess I'm giving for psi.
I have a question.
Yeah.
Can fsol do only one variable?
It can do multiple variables in as many functions. So if you have, in fact, I'm going to show you the next example, is 2 equations in 2 unknowns. fsol can handle any number of equations in as many number of unknowns. But when I say any number, you cannot put a billion equations because MATLAB resources will crash. In principle, it will work for any number of equations. Okay, any questions? Now, let me set a breakpoint here and start running this function. Where is the editor window? So it plotted it, it listed it and all, and then it is going to pass control to fsol. Okay, but fsol is a built-in function within MATLAB. It's in the toolbox, right? So I don't want to trace through that, but I might be curious to see how does fsol pass the value to the function that I wrote, which is flash L, right? So I might want to set a breakpoint within flash. What I'm trying to show you is how the control is coming to flash L. How does the value of psi change? We are not doing anything at this stage. When I hit the next button at this stage, it's going to go to fsol. fsol is going to call flash L, passing a value of psi. What do you think it will pass? 0.3, because that's what I've given. But you will see that it will make that call many, many, many times before control comes back to me on line 13. Every time it will keep changing the value of psi, searching to drive it to 0. So let's see whether it happens. There it is. So what is the value of psi? 0.3. Okay. And I'll continue. When I continue, it comes back here. What happened? It passed the value back to fsol. fsol examined the value of f, not 0, so it sends me another value. So psi will have a different value. And it's job of this function to return the function value. But you'll find that it still has the same value, right? It takes a few iterations for it to change. I don't know why. Don't ask me that. I've noticed this. So this is the third time I have hit. Okay. Now it's trying a value of 0.1929 for psi. Okay. And continue this next time. Same value. Okay. And continue this. Now same value again. It's maybe changing in the 4 significant digits. But you can also, if you set the breakpoint here instead of there, you can do something nice. You can calculate what is the function value. It's already 10 to the 9. It already narrowed it down to 4 significant digits. That's why it's not changing anymore, right? Because the function value is 10 to the minus 9. Okay? It is going to go down to 10 to the 14 maybe, because that's a default tolerance. I think it's done. So the control went back to here, and so there is the value of psi. You can ask what is the value of psi, converged value of psi, 0.1942. Now this is only 4 digits, so if you want to see format long and then psi, it will give you 14 digits accuracy. Now is it really 0? You can make a call to flash L and pass this value of psi. What would you expect? Close to 0, right? Oh, what did I do?
You didn't pass
I
K.
didn't pass K and L. And L? Oh my God. It's a breakpoint there. There, 10 to the minus 10. Okay, the function is 0 to 10 significant digits. So I think I covered everything I wanted to cover. How to show fsol and how to do the publish. And I've kind of gone slow because I know there are people that have not used MATLAB before, but that's it. You don't get any more help on fsol. You need to solve in the next assignment maybe 3 equations, 4 equations using these set of tool sets. Any questions? Yeah.
On my MATLAB, I know how to take total commission fee.
You don't have?
Yeah.
Which version of MATLAB is that?
2016.
Hmm?
2016.
2016? You don't have?
I only have O, plots, apps, that's all.
You can customize these things. They keep changing this from version to version, so I need to struggle through this. Create a new document. Open. Layout. Do you have a layout under home?
Yeah.
Okay, so when you open that, do you get organize layout, 3 columns, current folder, workspace, panels, shortcut. Oh, do you have the current folder?
Yeah.
Do you have any M file there? Or just type edit. Go to the command line, type edit. So it opens up an editor window on demand, and then it puts the folder there. These things are becoming very intelligent, I guess. Complicating things for us. Right? But what is the lesson from this? Be bold. Try it. It's not going to bite you, right? And that's the only way you learn. Okay? Any questions? Okay, so let's go to the next problem. Let me close this. The next problem is a CSTR. It's for non-chemical engineers, it's an example of a dynamic model, but we are going to look at both steady state and dynamic versions of this model. It's called a continuously stirred tank reactor. Essentially, it comes from a mass and energy balance on Actually, here you have the figure. Okay, so you have a reactor which is a cylindrical vessel with some liquid in there, and you have a stirrer to keep it homogeneously mixed. So there are no spatial variations. When you have spatial variations, we need to learn how to solve Navier-Stokes equation to look at velocity fields, etc. Here, the CSTR assumption says whether I sample the composition from somewhere here or somewhere there, composition is uniform, same. And it is the same as the exit composition. So I'm feeding some input, and at a certain flow rate F, certain temperature and certain concentration, and there is a reaction that is taking place that's exothermic, so it's producing heat. So I have a cooling coil that removes the heat. Okay, and then I'm producing a product at the same flow rate, different temperature and different concentration. So I give you a mass balance equation here, and in this course you'll be given the equation always, right? So you will need to understand how to solve it. That's where the focus is. So here is essentially the left-hand side is the rate of accumulation, and F times C is 0 is the input that comes in through that, and minus Fa times Ca, which is the output that goes through that, minus the amount that is converted in the reaction. Okay, and it is a first order reaction, so you have K here, but K is a function of temperature because it's a non-isothermal reaction, generates heat, and I have a cooling coil. And this is actually published in the 50s. If you analyze this problem, you could have gotten a PhD thesis out of it. Now it's an assignment, right? And it's a very rich problem. You will see that there are so many complicated dynamics from this that we will use this again and again to learn a lot of physics behind it. So the next equation is the rate of accumulation of energy equals energy coming in minus leaving through the feed streams plus the energy that is generated from the reaction. And what do you think is the last term? That's you can see that it has Fc in it. Fc is the cooling coil flow rate, right? So that appears here. So there is some amount of energy that is taken by the cooling coil that is immersed in the reactor. And it depends on the flow rate because it depends, the Nusselt number depends on Reynolds number. You need to know a little bit about the physics behind how to build these models. Later on, we will see those equations in greater detail. But this is basically where the equation comes from. Mass and energy balance for a continuously stirred tank reactor. And there are, if I ask you the question, what are the variables that I'm interested in solving from these two equations? Looking at concentration and temperature are the dependent variables. Time is the independent variable. It is a transient, dynamic, lumped model in our classification of schemes. So I cannot use fsolve to solve this particular problem. Okay, and I can use COMSOL, and COMSOL 0D will still work because I've ignored spatial variations. And there are a number of other symbols that I have introduced here. There are about 15 of them. V, rho, CP, R, T, E, etc. Right? These are all parameters in the problem. So I have to specify what these values are. Okay? And that's what I have done in this table. So the table that you see on the right hand side, top, okay? So F is the flow rate. I'm giving it as 1 meter cube per minute. But I'm also identifying that it's a possible manipulated variable. What does that mean? I could change the flow rate. CP I cannot change, right? V, once I've designed the reactor, I cannot change. Volume of the reactor is going to be constant. But I can change the inlet concentration. I can change the inlet temperature. I can change the coolant flow rate. So these are all highlighted ones are possible manipulated variables. And we will look at the dynamics of this by solving with MATLAB and with COMSOL. We will solve, in fact, steady state problem too. So what does the steady state problem look like? If I let C and T, Ca and T, not change with time, that's what steady state is, right? Once it reaches a steady state, once I start this reactor, it's operating under steady conditions, I'm feeding it at a steady flow rate, both the coolant and the reactant, and I'm producing product at a steady rate. So the left-hand side should be equal to 0 because concentration is not changing with time, temperature is not changing with time. What does the problem become then? Two nonlinear algebraic equations and two unknowns, Ca and T. So you can put these in the form of f of x p equal to 0, this p is this entire parameter set that you see, and x is going to be a vector consisting of Ca and T, the concentration and temperature. So I will write a function in MATLAB that will consist of two equations. F1 would be the first equation here. F2 would be the second equation there. Okay? And I will pass a vector x, and the first element of x will be Ca, the second element of x will be T. So inside that function, I will interpret x1 and x2 as Ca and T, and substitute all these values to evaluate those two functions, and return that function as a vector consisting of two elements. fsolve will interact nicely with that function. It will send two values, get two functions, and see whether the two functions are 0. If not, change those two values and iterate on that process. So the same fsolve will handle 2 by 2 or 20 by 20, it doesn't matter. Okay? Any questions on the problem? Now, what do we mean by a solution to this particular model? The solution to this full-blown model with the left-hand side not equal to 0 is a dynamical one. So that means generate for me plots of Ca as a function of time and T as a function of time. So starting from some initial condition, it may do this. When it levels off, it means it has reached a steady state. If you are interested only in the steady state, then I need to use only the right-hand side function, pass it to fsolve. I'll get these numbers. What is the final concentration under steady state? What is the final temperature under steady state? That's the solution to the nonlinear algebraic problem. But when I say nonlinear differential equation, the solution is the entire curve. Okay? Starting from any initial condition, what does the trajectory look like? Suppose I change the initial condition to something else. It may do this. That is, if there is only one steady state, it's going to go to the same steady state, starting from a different initial condition. The time it takes may differ. Yeah. For example, if I give this as my initial condition, it's going to go straight. That is, if I give my steady state as my initial condition, the functions are 0. Functions are 0 means dc dt is 0, dt dt is 0. So it's going to be flat curve. Right? Am I making sense? Or
Yeah.
okay? So now I'm going to kind of accelerate. I spent a lot of time on a simple problem. This is a slightly more complicated problem. We will look at more complicated physical response to this problem, but I want to show you the function. How does that function look like? So I wrote again as a script and a function, and this is a script file, and I have a corresponding function file for steady state and a function file for dynamic part. Okay, and I will upload all these into Moodle after I discuss them in class. So what does the script file contain? The first thing that I do is, I didn't want to write it because it's a fairly long function. Okay, so the clear command essentially clears the workspace. It's a script. Okay, and then I'm defining all the 15 parameters in the problem. I pack them all into a vector, par1, par2, par3, etc. Par1 is the flow rate, par2 is the volume of the reactor. I comment them so that I know what the values are and what the units are. So I packed a vector called PAR, the parameters in the problem, packed them with numbers, and I have as a vector. Then I have x0 equals 0.2 and 380. Remember, x is a vector consisting of two elements, concentration and temperature. So the first element is a guess for concentration. The second one is a guess for temperature. If it's a dynamic problem, it's an initial condition. If it's a steady state problem, it's an initial guess to fsolve. Okay? And here I told you that you have to figure out what option does. I'm using fsolve again. So I'm showing how to use fsolve. And fsol is going to call a function called CSTRFN. I'll show you how that function looks. It is going to take two values, x and PAR. X is going to consist of two elements, concentration and temperature. PAR is going to consist of 15 elements with all these numbers. Okay? And then x0 is the initial guess that is defined here. Right? So fsol transfers the control to CSTRFN with all these values and with these options. The option simply says reduce the error to 10 to the minus 7, that's enough. Don't go for 10 to the minus 10 or 12. Okay? So that's a tolerance function. That's how you specify what that error is. And display off means don't print out any garbage as you're trying to do this guess back and forth. Okay? And you can turn it on if you want to learn what output fsol produces during its iterations. And of course, what comes out of fsol is xs, vector, steady state. I'm calling it xs for a steady state value, and it will contain two numbers, converged value for C and T. Okay, and I'm just printing that in the next line. Okay, so I'm going to set let me set a breakpoint here, and then I have to show you the other function, CSTRFN. CSTRFN takes two inputs, a vector for the unknowns and the vector for the parameters. Here I switched it deliberately to y to show you that inside what you call it doesn't matter, right? It's a local variable. But the two values that are passed from fsol will be stored in y1 and y2. Okay. And the pair value, I'm putting it back into the original symbols. I'm unpacking them. Why do I unpack them? So that my final equation looks exactly like it's given. These are the two equations. So y1 and y2 are the guesses for the two vectors. I unpack them also. I take y1 and put it into CA, take y2 and put it into T. And then this equation looks exactly as it was given to me using the same symbols. F times CA naught minus CA minus B times K naught EXP, etc. Okay? So it's easy for me to read. But otherwise, if you don't want, you can use part 1, part 2, part 3, substitute it there. It doesn't matter. But I'm calculating these two functions and they go back to fsol. Any questions on that? I will upload these functions so that you can study them in greater detail, but conceptually it is the same as we saw in the previous case. Okay? And I guess we are almost out of time. So let me just run this script up until this point. So right now it has solved for fsol, and it gives me the value of 0.2646 for concentration, 393.95 for the temperature. And you can verify it at this stage if the function is 0 by simply calling CSTR directly, passing XS to that, and then the pair values. What do you expect from that? You will get two numbers which are close to 0, right? So 10 to the minus 12, both are multiplied by 10 to the minus 12. The first one is 0.002, the second one is 0.2086. So it's about 10 to the minus 12 accuracy in the function being equal to 0, both the functions. Okay? And I think we'll stop there and continue. The next one I'm going to show you is the idea of continuation. How do I solve this problem as I change the flow rate, for example? Some very funny things happen in this problem, and we'll talk about it next class. Okay? Any questions that you need help with your assignment? Maybe email me if you have any questions or doubts, because I think it's due by Monday, I guess, right? Yeah. We will have a meeting before that. I have set that deadline as I think 8 p.m. on Monday. Okay, if you want me to move it to 12 midnight, I can do that. But I will not move the deadline. Once we all agree, we need to make sure that you upload by then. Moodle shuts off after that. Okay? All right. Now, how was the pace today? Okay? And those that don't know MATLAB, are you guys doing okay? All right. 2, 4, 6, 8, 10, 12. Okay. All right. So we'll see you on Monday. Yeah.